कैसा लिखा?
मैं बोर्ड पे सब कुछ रखना था।
एक बार बाहर चल। वो दिखाऊंगा, ओपन करके दिखाऊंगा।
Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. This is Shravan Kumar, Senior Chemistry Faculty. In this session we are discussing about the electrochemistry. So, in this session we are discussing about the electrochemistry. So, what's the use of the electrochemistry? Echo.
Engage.
Okay. So, in this session we are discussing about the electrochemistry. What's the use of the electrochemistry? For what purpose we are discussing the electrochemistry? So that is, electrochemistry is the branch of chemistry. In this chapter we are discussing about the how electrical energy is converted to chemical energy, how chemical energy is converted to electrical energy. That means how chemical reactions takes place by using of electrical energy, and how electrical energy is produced due to chemical reaction. So all these are we are discussed under this chapter. How batteries are reacted, how what are the changes takes place during the chemical reaction, how current is produced, all are also discussed under this chapter. So in this chapter, first of all we are discussing about the here what type of cells we have in electrochemistry. So that is, we have the two type of cells. What are the two type of cells? That is electrochemical cell, and second one is the electrolytic cell. So what is the definition of electrochemical cell? So electrochemical cell is nothing but the cell in which current is produced due to chemical reaction. So current is produced or electrical energy is produced due to chemical reaction. The type of cell is known as the electrochemical cell. So in this cell, current is produced or electrical energy is produced from chemical reaction. So see the definition of electrochemical cell, that is a device is used to convert chemical energy produced in a redox reaction into electrical energy. That means electrical energy is produced due to chemical reaction. The type of cell is known as the electrochemical cell. And second type of cell is electrolytic cell. Electrolytic cell is nothing but reverse of this electrochemical cell. So what's the reverse means? Here in electrochemical cell, what happened here? Current is produced due to chemical reaction. But here reversed. What's the reverse? Due to chemical reaction. Chemical reaction takes place due to current consumption. So current is consumed to cause the chemical reaction. The type of cell is known as the electrolytic cell. See this one, the definition. The device in which chemical reactions are takes place due to electrical energy. That means electrical energy is consumed to cause the chemical reaction. The type of cell is known as the electrolytic cell. That means here we have the two type of cells. What are the two cells? Electrochemical cell and electrolytic cell. Electrochemical cell, what happened? Current is produced due to chemical reaction. Here, electrolytic cell is nothing but chemical reaction is takes place due to current consumption. Now, what are the differences between these two cells? See, the differences are, first of all, electrochemical cell. Here, electrolytic cell. So, what is the electrochemical cell? That is, here, what is the first point? Current is produced. What about the electrolytic cell? In this electrolytic cell, current is consumed. Current is consumed. Here, current is produced, current is consumed. This is the major difference. In this one, here in electrochemical cell, we get the anode and cathode. Here also we have the anode and cathode. Here cathode is having the negative sign, anode is having the positive sign. But in electrochemical cell, reverse the signs. So anode get the negative sign, cathode get the positive sign. Here what happened in electrolytic cell? The electrons are loosed. Losing of electrons is known as the oxidation. So the oxidation reaction takes place at anode. Simultaneously at cathode, electrons are gained. Gaining of electrons is known as the reduction. So reduction reaction takes place. So here also same. Here oxidation reaction takes place at anode. At cathode, reduction reaction takes place. Both reactions are same, but the signs are different in electrochemical cell and electrolytic cell. Next, here, what are the differences between electrochemical cell and electrolytic cell? Here, in this one, here also redox reaction takes place. Here also redox reaction takes place. But the major one more difference is, here in this one, ions get discharged at both electrodes. Ions are discharged at both the electrodes. But here ions are discharged at only cathode, not at anode. So this is the major differences between two cells. One is the electrochemical cell, another one is the electrolytic cell. So this is the one more difference in between these two. Okay. Sorry. Electrochemical cell and electrolytic cell. Now we are discussing about what is the electrochemical cell. So in this electrochemical cell, see the construction of the electrolytic cell or electrochemical cell. This is a diagram of electrochemical cell. Based on this one, what are the things we are observed? That is, it consists of two half cells. So it consists of two half cells. Left side cell is known as the anode half cell. Sorry. Anode half cell. Right side cell is the cathode half cell. So here electrochemical cell is consist of two half cells. Left side cell is known as the anode half cell. Right side cell is known as the cathode half cell. So in this anode half cell, we use the zinc electrode. This zinc electrode is acting as anode, whereas cathode half cell consists of copper electrode. So this copper electrode is acting as cathode. Because of to pass the current, two electrodes are required. One is the anode, another one is the cathode. So that's why left side half cell we are using the zinc electrode, which is acting as anode. Right side half cell we use the copper electrode, which is acting as cathode. Now these two are connected through the external circuit, and here it is the salt bridge. These two half cells are connecting through the salt bridge. And in this one, electrolytic solution we are used, that is in cathode half cell we use the copper sulfate solution, which is acting as electrolyte. In left side also we use the electrolytic solution, that is ZnSO4. Zinc sulfate solution is used, which is also acting as electrolyte. So this is the construction of the cell. So what is the construction? It consists of two half cells. First one is the anode half cell, right side is the cathode half cell. In anode half cell we use the zinc electrode. This zinc electrode is acting as which one? Anode. Right side cell consists of copper electrode, which is acting as cathode. Here in this one we use the zinc sulfate solution, which is acting as electrolyte. Right side is also we are using the electrolyte, that is a copper sulfate. Okay, this is the construction of the cell. Now here what are the changes that takes place? That is, to initiate the reaction we are passing the little bit current. When we are passing the current, what are the changes that takes place in left side reaction? Anode cell, and here cathode half cell. See the what are the changes that takes place in this anode half cell and cathode half cell. See, when we are initiate the reaction, then left side zinc sulfate is present, which is when we are passing the current, it is splitted into ions Zn plus 2 aqueous plus sulfate SO4 minus 2. Simultaneously right side copper sulfate we are taken, CuSO4. So CuSO4 is dissociated into Cu plus 2 SO4 minus 2. These are in the form of aqueous. Simultaneously in left side zinc electrode is present. The zinc electrode is dissociated into Zn plus 2 electrons. Whereas, so see this one, this is converted to aqueous by the absorption. Here what happened? Number of ions are increases. In left side anode half cell, what you are observed? Number of zinc ions are increases. So comparatively negative charge, positive charged ions are more. So what happened here? Left side positive charge is generated. More positive charge is generated. And here number of ions are increases according to solution. Number of ions are increases, then what happened? Concentration of the solution is also increases. Concentration of solution is also increases. So number of ions are increases. If number of ions are increases, then what happened? Concentration of the solution is also increases. And here due to increasing of number of ions, which ions are increases? More positive charged ions are increases compared to negative charge. So that means more positive charge is generated in left side. See, go for this one. Here the two electrons are produced. The two electrons are going to the cathode half cell through the external circuit like this. Two electrons are enter into the right side cell. So by when it is enter into the right side cell, then what happened here? Copper ions which are present in aqueous medium, that is gain the electrons, then converted to copper in the form of solid. By this one, we have observed that number of positive charged ions are decreases. Positive charged ions are decreases means indirectly negative charge is overcome, is more. Right side of cell which charge is more negative charge is present in right side. And what happened? Number of ions are also decreases because of copper ions are converted to which one? Solid form. Ions are decreases. Number of ions are decreases. Then concentration is also decreases. Left side cell concentration increases. Right side cell concentration decreases. Why concentration decreases? Because of number of ions are decreases. Why number of ions are decreases? Because of 2 electrons are gained. So gaining of electrons is nothing but right side which reaction is takes place? Reduction reaction is takes place. Due to reduction reaction, here number of ions are decreases in right side cell. So concentration of the solution is also decreases. So and here which charge is more overcome? That is negative charge. See left side which reaction is takes place? That is oxidation reaction is takes place because of losing of electron. Due to oxidation reaction, what you are observed here? Positive charge is overcome then compared to the negative charge. So after some time what happened? This process is going on, and after at certain point, right side only negative charge is existed, left side only positive charge is existed. Okay, so due to this one, so to the reaction will be stopped because of to pass the reaction or to cause the reaction both charges are required. But after some time what you are observed? Left side only negative charge is existed, right side only positive charge is existed. So due to this reaction has been stopped. Okay, so reaction will be stopped. To prevention of this, we use the salt bridge. What's the use of the salt bridge? If you are not using the salt bridge, then what happened? Reaction will be stopped. To prevent this reaction, we use which one? Salt bridge. What is a salt bridge? That is, salt bridge is a inverted U-shaped tube. This is a salt bridge. In this one, we use only particular components like potassium chloride or potassium sulfate, etc. Only we are using this type of salts. See, so in this one, it is consist of a solution like inert electrolytes like potassium chloride, potassium nitrate, potassium sulfate, ammonium nitrate. Only these components are only used. Why we are using this one? And before that, these are associated with which one? Agar-agar gel and gelatin. A mixture of these components. What are the mixture? Potassium chloride, straight, so potassium chloride plus agar-agar plus gelatin. This mixture is used in this salt bridge. Why we use only these components, not other than components? Because of when you are taking this one, potassium chloride is splitted into K plus and Cl minus ions. Different ions are migrated with different velocities. But in this one, the mobility of K plus ion is must be equals to mobility of Cl minus. So that is called as transport number. So for potassium chloride, the transport number of K plus ion is must be equals to transport number of Cl minus. So due to similar transport numbers, that mixture is used in salt bridge. So what is the transport number? Transport number is nothing but here velocity of positively charged ion to the, here U plus is the mobility of cation, U minus or V, V is nothing but mobility of anion. This ratio is known as the transport number. So transport number of T plus ion is equals to, see, transport number of cation is equals to mobility of cation by mobility of cation and anion. Similarly, transport number of anion is equals to mobility of anion by total mobility. So if you add these two, mobility or transport number of cation and anion, if you are added, the denominator values are same, so numerator values are equal. So we get U plus V by U plus V. So we get 1. So due to similar transport number, we use this component. Suppose if you take the transport number of K plus is equals to, or transport number of NO3 minus. Similarly, transport number of potassium is equals to transport number of sulfate. Similarly, transport number of ammonium ion is equals to transport number of nitrate. So due to similar transport numbers, these are only components are used in salt bridge. Now what's the another importance of the salt bridge? That is, this one is transfer the only charges, not the mass. Only transfer the charge, not the mass. Due to, because of, if you are observed in galvanic cell or voltaic cell, left side which charge is more? That is more positive charge in left side. Just now only we have discussed. Right side only negative charge is present. If there is no salt bridge, then what happen? Reaction will be stopped. But to overcome this, we use this salt bridge. In this one, which mixture we are used? KCl, that is K plus Cl minus. So left side which charge is overcome? Positive charge is more. So that's why negatively charged Cl minus ions are migrated towards the left side of cell, and K plus ions are migrated towards the right side half cell. So due to migration, this one, charges are transferred, not the mass. Due to transferring of charges, here positive charge is neutralized with negative charge. So reaction became neutral. Here also right side, which charge is migrated? Positive charge is migrated. So that's why right side is also became neutral. So that means when we are using this salt bridge, here what happened here? Left side only Zn plus 2 ions are more. Right side sulfate ions are more. So to overcome this, what happened? Salt bridge is used. Cl minus ions are migrated. Right side K plus ions are migrated. Due to this, what happened here? Charges are neutralized. Then reaction became neutral. Reaction became neutral means then reaction is continuously takes place. Reaction is continuously takes place. And one more thing also we are observed. Left side what happened? Positive charge will be increases because of zinc solid form is converted to Zn plus 2 aqueous. Right side what happened? Cu plus 2 aqueous. Gain the 2 electrons, then converted to copper solid. What you observed? The electrode of anode will be dissociated. So that means mass of zinc electrode is decreases. What you observed in right side? Mass of copper electrode is increases. So sometimes they ask the question, in which side mass of the electrode is increases? So in which side mass of the electrode is increases? that is right side, that is a cathode half cell. In cathode half cell, mass of the electrode is increases. And what happen in anode half cell? Mass of the electrodes are decreases. And in which side concentration increases? Left side concentration increases, right side concentration decreases. So electrons are flow from which side to which side? Left side to right side. Which side oxidation reaction is takes place? That is left side oxidation reaction is takes place, right side reduction reaction is takes place. Now, here in this one, we are discussing the electrode potential of the cell. So, what are the changes that takes place in this reaction? That is, in this one, electrode potential of the cell is calculated by using of this formula. So, what are the reactions that takes place during on this reaction? That is, in a cell, oxidation reaction is takes place in left side, reduction reaction is takes place in right side. What is the liquid junction potential? ELJ. ELJ is nothing but liquid junction potential. Liquid junction potential is nothing but, what's the definition of liquid junction potential? See this. When two electrolytic solutions are directly in contact, that is, here ZnSO4, here which one is present? Potassium chloride. These two are directly in contact with each other. Where it is? Potassium chloride is present in which one? Potassium chloride is present in salt bridge. Zinc sulfate is present in left side half cell. These two are directly in contact with each other. Then what happened? Ions are moves across the junction with different speeds. How it is? Because of left side only positive charge is there, so that's why charges are transferred. So which charge is transferred here? Negative charge is transferred. Due to this one, here what happened here in between these two, a junction potential is existed, liquid junction. That means due to different velocities, we get the difference in speed. Due to this one, potential is developed. That potential is known as which one? Liquid junction potential. But here that liquid junction potential is considered as which one? 0. Because of, in this one, the transport number of K plus ion is equals to transport number of Cl minus. So due to similar transport numbers, there is no change in potential difference. So that's why that value is taken as which one? 0. So sometimes they mention this value, so that's why you have to remember. So what's the electrode potential of the cell? That is, in this cell, three potentials are takes place. There is the oxidation potential, reduction potential, liquid junction potential. Liquid junction potential is nothing but, this is a definition. When two electrolytic solutions are directly in contact, ions moves across the junction with different speed. As a result, a potential difference is developed at junction, that is called as the liquid junction potential. So what's the liquid junction potential value? That liquid junction potential value is taken as 0. Why liquid junction potential value is taken as 0? Because transport number of K plus ion is equals to transport number of Cl minus. So if it is the potential is developed in left side, it is a suppose positive value. Right side what happened? Same value generated with opposite side. So that means total value became 0. So that means liquid junction potential value is taken as 0. Now see representation of the electrochemical cell. What are the reactions that takes place in left side? See, solid form of zinc is converted to Zn plus 2 electrons existed in aqueous form. What is the reaction is takes place in right side? Cu plus 2 aqueous gain the 2 electrons, then converted to copper in the form of solid. So what happened? Zinc is converted to Zn plus 2. So zinc converted to Zn plus 2. This one is indicated by slash. Slash indicates conversion of zinc electrode into Zn plus 2. Right side what happened? Cu plus 2 aqueous is converted to Cu. The conversion is represented with which one? Slash. So the slash is indicates the conversion of the electrode. See, so in the electrolytic cell, what happened here? Both reactions are takes place. Oxidation reaction and reduction reaction is takes place. So oxidation reaction is always takes place at which side? Left side. So that's why we mention the oxidation in left side. Oxidation reaction in left side. Right side, which reaction is takes place? Copper is converted to Cu plus 2 is converted to Cu. That is reduction reaction. So reduction reaction is takes place in which side? Right side. So oxidation reaction is written on left side. Reduction reaction is written on right side. So these two are connecting through the which one? Salt bridge. So the two parallel lines are indicates the presence of salt bridge. So salt bridge is represented with which one? Two parallel lines. So what's the oxidation reaction? Zn is converted to Zn plus 2. What's the reduction reaction? Cu plus 2 is converted to Cu. And here, left side which reaction we are written? Oxidation reaction. Right side, reduction reaction. Oxidation reaction is takes place at which electrode? Anode. Simultaneously, reduction reaction is takes place at cathode. So that's why anode half cell reaction, two parallel lines, cathode half cell reaction. So the parallel line indicates salt bridge. This is a representation of the cell. So in this one, see, E oxidation plus E reduction, but liquid junction potential value is taken as 0. So that's why this is a representation of the cell. Suppose, see, based on this one, Ag is converted to, sorry, just wait. Cu is converted to Cu plus 2 solid form, aqueous plus 2 electrons, and sorry. Okay, sorry. See here, Ag plus gain the electron, then converted to Ag. Now what's the overall reaction in this? That is, to balance this one, I am using this multiplication with 2. So 2 electron get cancelled, then converted to Cu solid, to Ag plus, this is the aqueous medium, is converted to Cu plus 2, that is aqueous plus Ag. So in this one, what is the representation of this cell? The representation, left side is always which reaction we have to mention? Oxidation. Right side we are always mention the reduction. So what is the oxidation reaction? That is, copper is converted to Cu plus 2. So Cu is in the form of solid, Cu plus 2 is in the form of aqueous. So slash indicates conversion. And right side which reaction we have to write? Reduction. So what is the reduction reaction? Silver ion is converted to silver. So Ag plus is converted to Ag. So this is a solid, this is a aqueous. Both are connected through the salt bridge. So in this way we represent the any type of cell. Always left side we have to mention the oxidation reaction, right side we are mention the reduction reaction. Oxidation reduction both are connecting through the salt bridge. That means overall redox reaction is takes place in galvanic cell or electrochemical cell. Now here in this one we get the new term, that is the oxidation potential, this is the reduction potential. So what is the oxidation potential, what is the reduction potential? So that is, see, oxidation potential and here it is the reduction potential. What is the oxidation potential? Suppose if you take the zinc, what you are observed in this one, zinc electrode is converted to Zn plus 2 by losing of electrons. Now what happened, zinc electrode is try to lose the electron. The capacity of losing of electron, that is known as the oxidation potential, or the tendency of losing of electrons by the electrode, that is known as the oxidation potential. So what is the statement? That is tendency of losing of electrons, that is known as the oxidation potential. That is represented with which one? E oxidation. The capacity of losing of electrons is known as the oxidation potential. Now what is the reduction potential? So reduction is nothing but, if you take the copper in right side, aqueous, gain the 2 electrons, then converted to which one? Copper solid. What you observed, copper is try to gain the electron. The capacity of gaining of electrons by the electrode, that is known as the reduction potential. So what is the reduction potential? The tendency of gaining of electrons by the electrode, that is known as the reduction potential. That is represented with which one? E reduction. Oxidation potential and reduction potentials we get. Suppose if this oxidation potential values are measured at or E oxidation. So if oxidation potential values are measured at 1 atmospheric pressure, 298 kelvins, and for 1 molar solution. Okay, oxidation potential is measured at which conditions? 1 atmospheric pressure, 298 kelvins, and 1 molar electrolytic solution is if you are used. That potential is known as the standard oxidation potential. Okay, so E naught indicates standard oxidation potential. So standard oxidation potential. What is the difference between E oxidation and E naught oxidation? That is, this is measured at any condition, but here it is measured at 1 atmospheric pressure, 298 kelvins, and 1 molar solution. If you measured at this condition, that oxidation potential is known as the standard oxidation potential. Next, here if reduction potentials are measured at same condition, what is the condition? 1 atmospheric pressure, 1 molar solution, and 298 kelvins. That is known as or called as standard reduction potential. Okay, so oxidation potential, standard oxidation potential, reduction potential, standard reduction potential. So what are the differences between these two? If oxidation and reduction potential values are measured at any condition, but standard values are measured at 1 atmospheric pressure, 298 kelvins, and for 1 molar electrolytic solution we are measured, that is known as the standard oxidation potential and standard reduction potential. So next, here in this one, experimentally reduction potential value and oxidation potential values are equal, but the signs are different. That is, reduction potential values are positive values and oxidation potential values are negative value. Or if potential value is more, if potential value is more, that is the reduction potential. If potential value is less, less value is nothing but that is indirectly oxidation potential. So we get the confusion because of oxidation potential, reduction potential, standard oxidation, standard reduction. So we get this some difficulty. So that's why instead of this we use the reduction potential. We use the which term only? Reduction potential value only we are used. If the reduction potential values are more, then I will change this one. If potential values are more, reduction, potential values are less, oxidation. Or if always potential values are measured in terms of which one? Reduction potential. So that is, if reduction potential values more undergoes reduction reaction. This is a shortcut method to remember. If reduction potential values are less, it undergoes oxidation reaction. Whatever the values are given, the highest value should undergoes to the reduction, lowest value is undergoes to the oxidation. So based on this, electrode potential of the cell is written as E reduction plus E oxidation, but oxidation potential value get the negative. So that's why finally what is the potential of the cell we are getting? E reduction minus E oxidation. Let's take the one example. Suppose X, Y is given. So first of all, X element, Y element. For this potential value is minus 0.52. For this minus 0.53. So both values are given. So this is a volt, this is also volt, electrical volt, EV. Now, which is undergoes to the oxidation, which is undergoes to the reduction? That is based on this. What is the value? Reduction potential is more, undergoes to the reduction, less undergoes to the oxidation. Which is the more value, which is the less value? Out of these two, this is a more value, this is a less value. More value undergoes to the which reaction? Reduction. Less value is undergoes to the oxidation. Now, electrode potential of the cell is equals to, what's the equation we are getting? E reduction minus E oxidation. Substitute the values in this. So reduction, what's the value? Minus 0.52 minus of E oxidation. What's the oxidation? Minus of minus plus 0.53. So what's the value we are getting? 0.01 EV, electrical volt. So always electrode potential value is positive, not the negative. For getting positive electrode potential values of the cell, we choose this. So whatever the values are given, highest value is undergoes to the reduction, lowest value is undergoes to the oxidation. So in this way we are calculate the electrode potential of the cell. Suppose sometime we don't have the any salt bridge. Suppose there is no availability of salt bridge. At that condition, instead of salt bridge we can use the porous membrane or semi-permeable membrane. If semi-permeable membrane is used in galvanic cell, that is known as Daniell cell. So what is the difference between galvanic cell and Daniell cell? That is, in galvanic cell we use the which one? Salt bridge. In this one we use the which one? Porous membrane. So in this one, what is the porous membrane? That is a semi-permeable membrane. What is the nature of the semi-permeable membrane? That is, it allows only solvent molecules but not solute. It allows only which particles? solvent molecule but not the solute particle. That is called as the semi-permeable membrane. That is the specialty of the semi-permeable membrane. So this is the construction of the semi-permeable membrane. So this is the semi-permeable membrane. See, porous part is made up of with which one? Semi-permeable membrane. Outside we use which one? Copper sulfate. Inside we use which one? Zinc sulfate. And this is the semi-permeable membrane. So this is the semi-permeable membrane. Similar reactions are same. What happened here? Zinc is converted to Zn plus 2 electrons, aqueous, solid. Here what happened? Again Cu plus 2 aqueous, gain the 2 electrons, then converted to copper. See the overall reaction. Zn plus 2 plus Cu. Same reaction is takes place. But what is the difference? Instead of salt bridge we use which one? Semi-permeable membrane. This is a major difference between Daniell cell and galvanic cell. Okay, understood. So now we are discussing about the some questions in this session. So till now we are discussing the what is the electrolytic cell, what is the galvanic cell, how the galvanic cell is worked, what are the reactions that takes place, what is the role of the salt bridge, okay, how to represent the cell of the reaction, all we have discussed till now. Now this is a time for the solving the questions. See, so what is the given question? See, which of the following statement is correct? 4 options are given. Out of 4 we have to choose which option is correct. See, cathode is negative terminal in both galvanic and electrolytic cell. Just now only we have discussed. That is galvanic cell, electrolytic cell. So in galvanic cell and electrolytic cell we use the anode and cathode. Here also anode and cathode. What is the sign of the cathode in general electrolytic cell? That is negative charge. Here it is a positive charge. Reverse. Here negative, here positive. That means cathode and anodes are having the same signs or opposite signs? Opposite sign. But what is the first one? Both terminals are having the same charge in galvanic cell and electrolytic cell. So this option is wrong. Go for next. Anode is positive terminal in both galvanic and electrolytic cell. So opposite signs we have. But what is the signs we have in this? Anode is having the negative sign in galvanic cell, positive sign in electrolytic cell. But what is the statement is given? Both are having the same sign. So that is the wrong statement. Go for third. Cathode and anode are negative terminal in electrolytic and galvanic. In electrolytic, see cathode. Electrolytic cell, what is the sign of the cathode? Negative. So cathode is correct. Next, in galvanic anode, what is the sign? Negative. So third statement is correct. So verification. By the verification, what is the answer is correct for this? Third option is the correct for the given question. Go for the next. Which of the following statements is correct about the galvanic cell? So see the 4 options. What is the first option? It converts chemical energy into electrical energy. Second one, it converts electrical energy into chemical energy. Third, it converts metal from its free state to combined state. Fourth one, it converts electrolyte into individual ions. So what is the correct statement? The correct statement is first one. So what is the statement? Galvanic cell. Galvanic cell is nothing but the cell in which electrical energy is produced from the chemical reactions. The type of cell is known as which one? Galvanic cell. So in this way we are discussing the galvanic cell. Based on that one we are solving the some problems. Suppose let us take the another one. What is the overall reaction based on this concept? That is always left side which reaction we are taken? Oxidation reaction we are taken. Right side which reaction we are taken? Reduction reaction. See, X is converted to which one? X plus 3. So plus 3 is formed due to losing of 3 electrons. Right side which reaction we are taken? Reduction. What is the reduction? That is Y plus 2 is converted to Y by gaining of 2 electrons. For balancing of this whole equation is multiplied with 2. This whole equation is multiplied with 3. So what happened here? 2x plus 3y plus 2 gives rise to 2x plus 3 plus 3y. This is the overall reaction. So based on this one, how many electrons are involved in this total reaction? 6 electrons. So in this way we are identify the reactions. If you are facing any problem while this topic, come to the nearest knowledge hub center. Then we are here to solve your problems. Thank you. In the time వచ్చింది sir. Okay sir.